All right, so it looks like really, honestly, the only thing I gave you was, hey, AOC and BOD are diameters. I didn't want to pass them out just for this proof, but if you have highlighters or colored pencils, it might help on this. Because take a look at those two triangles. I'm asking you to prove congruent. Everyone see they overlap each other. All right, so it might be nice just to see them in different colors. I'll do it up here on mine. ABD, this triangle right here. Let's try to get it congruent to CAD, this triangle right here. All right, I need any sides, angles. And hey, I want to make sure we're good here today. It doesn't have to be a circle fact every time. It can be anything we've used in proofs in the past. Anything. All right, but you can probably bet a circle fact or two will come up every proof, but it doesn't have to be all circle facts. It can be something we've used previously in proofs. All right, so look at those sides and those angles. Anything. I'll start with numbers on the next proof, but so I'll just go with contributions right now. Cormac?
BOD congruent to COA.
Yes, I'll take it. Why is that?
Because of diameter.
Yeah, we've never used that. What we've always used is all radii are congruent. Everyone agree? Well, if all radii, why aren't all diameters congruent then in the circle? Good, I like it. I'll use that. So we're going to say BD or BOD, yep, congruent to AOC in a circle. All radii congruent, or I did it too. All diameters congruent now. Way to see that. Way to see it. I thought somebody else was going to say another side, but that's fine. All right. Anything you see? What do you got there? You can put in the reflexive side. I'm not going to on this one because I know where this is going to lead to. But yes, make basically a choice between you two right here. Either do all diameters are the same, or Dylan just said AD congruent to AD reflexive, right? I'm not going to put that in because I know where this is going, but either the diameters or AD congruent to AD would go here in step 2, reflexive, okay? I just know where it's going, all right? And I don't need both of those, okay? Good, Dylan? I know where this is going. I don't need both of them. I'm specifically looking for any angles now you know are true. Any angles. What's up, Lexi?
Angle BOA and COD.
BOA, okay. You say they're vertical, right?
Yeah.
You can write that. Here's the problem I have with that. Okay, let me mark this. Is that a full angle in one of those two triangles? See, so I can't use it. See what I mean? Good? If you wrote it, it would be true, but I just can't use it. All right, yes, these are vertical. I get it, but they're not full angles in the triangle, so I can't use it. All right, we're getting there sooner or later here. We'll hit it. Dylan got something else now. I'll use this one. Go ahead.
Angle ABC and BA are right angles.
Oh. You guys that were here yesterday, we wrote this a ton. All right, you guys that weren't here yesterday, you might want to watch the video. Angle BAD is a right angle. So CDA. How does he know that? All right, we get to know our facts better and better before Monday. All right, what type of angle is BAD other than a right angle? It's inscribed. And look where it's drawn to. It's drawn to a. Where's it drawn to? BAD. It's drawn to a. What's BOD called? A diameter. All right, so we have angle BAD and angle CDA are right angles. And here you go. Here's the circle fact we use. You guys that were here yesterday, you're probably tired of writing this already. Inscribed angles drawn to a diameter are right angles. Again, if you're here yesterday, we wrote that a ton. And look, even if you're on the field trip or you were sick yesterday, it still doesn't, I don't want to say it's an excuse, but you watch the video, you're going to write it down 5 or 6 times as well. Now, what do I still need to say about those right angles? Congruent, right? That doesn't change. Angle BAD congruent to CDA. All right angles congruent. So now we have a pair of angles. So we have a pair of sides, the diameters, and a pair of right angles. We need one more pair to get these triangles congruent, right? And just so everyone's aware, I want to tell you this, why I'm not going with when Dylan said reflexive. Let me just draw one of these triangles. We'd have that, the diameter, and the right angle. We could use HL, but I didn't really want to go down that road. And it's not side angle side, so that's why I didn't do the reflexive with Dylan. So I'm looking for something else now, so I don't have to do HL. What's up, Finley?
Angle B and C.
Yes, let's go. Yes. You guys are here. I told you it was going to be a grind, and you're going to get upset, but now it's worth it today. Angle B congruent to angle C. How does she know that? Know your facts. Know your facts. What type of angles are B and C? Inscribed. Drawn to. Look where they're both drawn to. Not a diameter this time, but they're both drawn to same arc. There you go. That makes them congruent. 2 inscribed angles. Drawn to the same arc are congruent. Yes. All right, here we go. So it's either going to be angle side angle or angle angle side. Those diameters Cormac gave us, you guys got to figure out, are they in between these 2 congruent angles we just wrote down? That's what your job is right now. Are those diameters in between the angles we marked congruent or not? Because that's going to determine if it's side angle side or angle angle side or angle side angle. So triangle ABD congruent to triangle DCA. All right. Are they in between or not? Those diameters. Anybody confident? So they are not. They are not in between. So that's why we're going to use angle angle side. Whew. There we go. Questions there. We got 3 more to go, and now I'm calling on numbers. Just see what you got. All right, I'm done with that packet. Again, you guys that weren't here, you do it if you want. You know where the recording is. We're going to go to day 8 now. Day 7 in your packet. Day 7. And let's see what you have. Mark your diagram with whatever you want. Probably the givens that says they're perpendicular. Hopefully we're putting right angle symbols on there, right? Let's not forget, you guys, I know you guys are so involved in the circle facts. I got to know them, which is great. But don't forget about stuff in the past here. We see something's perpendicular to another segment. We got to put our right angles on there. All right, we got to put our right angles there. And we got to take a sniff of the proof statement, right? Angle CFW. Oh, there it is. And CEW need to be congruent. You guys know the deal, right? Those aren't going to be congruent unless what? Triangles. All right, so that's our first job. Get the triangles congruent using circle facts or anything we've used before. I'll start this off. Why not? My steps 2 and 3 are going to be telling you these are right angles and then they're congruent. I think we can all handle that. All right, so I'm going to tell you that these are EWC and CWF are right angles. Remember, perpendicular lines form right angles. And then I'll tell you they're congruent. And the rest is going to be on you guys. So there you go. I gave you a pair of angles to start out with, getting those triangles congruent. All right, now it's on you guys. Now it is on you guys. Anything you can tell me. I'll take anything, whether it be a circle fact or not. Look at those two triangles. Anything you know is true. All right, here we go. Lily, hello. Why not, right? Even though your classmates are hating on you right now for taking that. CW, yep, congruent to CW. Reflexive. There's a side. Now, can we take a look at this proof real quick? I haven't wrote down a single circle fact yet. So probably this last part, it's got to be a circle fact somehow. Right? I haven't written down a darn thing about circles yet. All right, so this last pair of sides or angles probably going to be a circle fact. And I'll give you, I don't want to give you a hint, but I don't think we talked about it even with you guys that were here yesterday. I don't think we talked about we reviewed this one. But we did do it the Thursday before break. We went over 4 circle facts before break. And I spent a lot of time on the 4th one because I knew it was going to get used a lot. And here it is. Here it is. That given does more than form right angles. Let's just say that. That given does more than form right angles. A radius perpendicular to chord EF. All right, we're ready. And be careful what you guys are writing down here. Some of you guys are trying to get ahead, and I'm like, Cormac, anything?
EW congruent to WF.
Okay, not yet. You're on the right track. Not yet. Right. Here's what we're using. Here's what the theorem is. Diameter, or part of a diameter, which this is a radius. If it's perpendicular to a chord, the chord gets what? Bisected. Good. Now, that's what the fact says. The chord gets bisected. The fact does not say, oh, the 2 little segments are equal. That's not what it says. Here's what it says. Diameter perpendicular to a chord, the chord, so OC bisects the chord EF. That's what it's saying. I want to make it perfectly clear. The fact doesn't say, oh, the 2 little segments are equal. That's not what it says. It just says, hey, whatever the chord's name is, it gets bisected. Diameter perpendicular to a chord bisects the chord. Again, it does not say the 2 segments are equal. That's going to come next, though, for a different reason. So here we go, a little review of this theorem right before break. Now you can say in step 6, sure, what Cormac just said, EW congruent to WF. Because of what now? No circle fact. Definition of bisects, yeah. Something we've done before. Definition of bisects. I love this proof because I want to make sure you guys understand how this theorem works if you write it down. You can only write down that something is getting bisected. All right, good job, Corin. Good job. All right, I think the triangles are congruent now, right? I think we got enough info. Step 7. Triangle EWC congruent to FWC. Still asking you guys, though. We're not done. What's the reason for those two triangles being congruent? Whew, there we go. Now let's go again. Stephanie, hello. What's your reason here? Yes, yes. Good job. And then we'll finish this off. We said we needed the triangles congruent to get those angles congruent. CFW congruent to CEW. And still going to ask, because the triangles are congruent, why are those angles congruent now? There we go, Jonathan. Good job. CPCTC, like we never left. All good. Again, really wanted to harp on when this theorem can be used. Not to say the pieces of the chords are equal, just to say the chord gets bisected. Still hungry? Yes, you are. Let's keep rolling. All right, look at this given. AB congruent to DE. Why did I write it with circle C in the givens? What use does that have to you guys? That you know this is circle C. Well, who cares? You know, at least C's the center now. That's huge. That C's the center. And in the proof statement, we're trying to get BX congruent to DY. You guys know that's not happening right away, right? What's got to happen first? I'm not getting BX congruent to DY without doing what? Proving the triangles. Let's do it. Proving the triangles congruent. Guys, we got a blank slate here. Blank slate. Nothing is given to us here. All right, because I can't count A, B, and D, E as sides. That's for darn sure. So it's on your own. Any circle fact or anything we've used in proofs before. Anything. I'll get your mind right here before I ask somebody. Anything goes. Look at those sides and look at those angles. Can you get any of them congruent for whatever reason? Circles or anything in the past? Oh, we are digging deep. We're going way back in the time machine here. All right. Anything. Anything. Finley, anything you want to add here?
XBC and YBC are right.
Why?
They're inscribed angles.
Are they? Where do inscribed angles, where do they have to be? On the circle, right? In XB would have to be on, remember this, that's an inscribed angle. Okay? That's not inscribed. It's not central either if you were thinking about central angles. Okay? Good? It's all right. It's all right. I want mistakes to happen. How about another pair of angles, though? Finley, you're not off the hook. How about another pair of angles that don't overlook it, don't complicate it? You don't need to know anything about circles to tell me these angles are congruent.
XCB and just C, the vertical angles.
Don't say angle C, though. Just give me all three letters. Come on.
YC. DCY and XCB.
Yes. Yeah, everyone agree? You're right. Because, again, one more time, what type of angles are they? Yeah, there you go. Verts. Everyone remember those bad boys. Vertical angles. Angle XCB congruent to angle YCD. Vertical angles are congruent. Whew, all right. One pair down, two more to go. Where are those other pairs? Remember, we are in a circle, and it's circle C. Stephanie, back to you. Anything you see? Say, I heard CE at the end. What was your first one?
AC.
Oh, all right, yep. AC congruent to CE. Why? Perfect. Now, unfortunately, I think Stephanie is, your classmates are looking at this and being like, why are you writing that down when those aren't even sides of the triangle, right? Well, you guys will have to see that. Because Stephanie's right on point. Why we need AC congruent to CE. I get it. They're not, notice I'm not putting an S next to it. They're not sides of the triangle. But here we go. Let's keep rolling with Stephanie's idea. How can I get it to become sides of the triangle? AC and CE with your givens. What can I do with those two to get BC and CD? Subtract. Oh, remember that back in the day? Subtraction. Yep, we're going to subtract here. AC minus the given AB equals, where am I going? CE minus the given DE. Yep, we got to do a little subtraction. Is anybody thinking, oh, you can do subtraction on radii? Radii are segments. That's all they are. They're just segments in a circle. You can subtract segments. You know that. And even though we're on unit 10 out of 12, guess what's going to come next? Oh, there you go. It's never, I told you it was never going to change. I don't care how far we are out in the year. Substitution to say BC congruent to CD. Good job, Stephanie. Good work. Perfect. I got a pair of sides. Come on now, one more to go. One more pair to go. Where is it going to be, huh? One more pair of sides or angles and circle C. C is the center. Circle C. One more pair of sides or angles. Woo! Woo! Shoom. Drew, here we go. Come on. Whoa, all right. Bringing some credibility to that group over there. Good. XC congruent to CY. Now, hey, you and I both have choices. I could make this step 6, or I could fit it in with, where'd I write it? Step 3. Because they're what, Drew? They're all radii. So if you want to make yourself look a little smarter, make your proof a little longer, you can put it in step 6. Or if you wanted to put it in along with step 3, you can as well, because they're the same reason. Good work, Drew. Woo! There we go, kids. Good work. Now the triangles are congruent. Why DC? How about that reason why they're congruent? Ooh, where am I going there? Not there today. Oh, 2 for 2. Nope, didn't go 3 for 3. Finley, let's go. A little redemption. There you go. Perfect. And then I got BX congruent to DY. How about a little reason for those segments being equal? Oh, top of the key, Zoli. Thank you. There we go. I love that subtraction came back here, just to show you guys anything's fair game at this point in the year. Anything. All right, little dessert now. You got it. Here it is. A little sweetness here for you. Ooh, notice the proof statement changed, huh? Similar. Can we just talk about that one before we get crazy with our givens? There was 3 ways to prove triangles similar, but we are in a proof, so there's really only one way. Angle, angle. Yep. So all you guys have to worry about is finding 2 pairs of congruent angles. That's all you need to worry about. Easier said than done. I got BT as a tangent to circle. Yeah, at point T. Ooh. Can we just get over this fact? T is the midpoint of arc CD. What 2 arcs have to be equal then? Midpoints work the same way as arcs as they do for segments. All right, so if T is the midpoint of arc CD, Can we start it here? What two arcs have to be congruent to each other then? Bryson, what two arcs you got for me that are congruent?
CT and TB.
Good. CT, arc CT, congruent to arc TB. So we can mark those arcs with hash marks being congruent. And that's just definition of a midpoint. All right, I'm gonna let you guys soak that in now. Can you find any angles? Because remember, it's just sides do not matter here. I don't care about the sides. I just want two pairs of congruent angles for some reason. Find me two pairs of congruent angles. Hey, if you get one and not the other, hey, that's fine, you know? Both are circle facts, by the way. Both pairs of congruent angles are going to come from circle facts. Anybody want to take a first pair of angles that you know are congruent, or you know something, anything that's true about any of the angles? I'll start there. Cormac, what do you want to say? Tell me.
CAT congruent to DAT.
Yeah, I'll take those. All right, those are the tougher ones I thought people were gonna have. Here's what Cormac said. Remember the two arcs we just had congruent? Look at these two angles up top here. Coming back to you here, Finley, now. Those are what type of angles? Inscribed angles, right? Those are, and look where they're drawn to. Not the same arc, but two arcs that are congruent, so they have to be congruent. Now, this was one we went over on Thursday, so let me write this carefully. Angle CAT congruent to angle BAT. Here's your reason. I had congruent arcs, so that's what I'm going to start with. Congruent arcs imply I have congruent, don't write the word just angles, be specific. What did we just say these were? Inscribed angles, right? So if I have two arcs that are congruent, the inscribed angles drawn to them are also congruent. All right, so I thought those were the tougher ones. Good find. One pair down, one more to go. And this other pair is circle facts. Circle facts. I see some of them marked on people's diagram. Anybody else know something true about this one? You guys that were here yesterday, you should at least see one of the angles. We wrote it down a ton of times. Alexi, what do you got right there at ACT?
ACT is a right.
Hey, ACT. That's a right angle for a circle fact. Which also means there's got to be a right angle in the other triangle to match it. Where's that right angle? Angle ATB. But for different reasons. In step 4, I'm not going to put both are right angles because they're right angles for different reasons. So let me go to the one Alexi gave us first. Angle ACT is a right angle. I'm going to go to you guys now and ask why. Why is ACT, or how do we know to put a right angle symbol there? I'll help you along. If you don't know, that's fine. One of our big facts here that we're going to use, big facts. Lily, you know?
Because the inscribed angle is with the diameter.
Perfect, perfect. You got it. Inscribed angle drawn to a diameter is a right angle. Good job. Now, let's talk about angle ATB and why that bad boy is a right angle. Not because it's an inscribed angle drawn to a diameter, for a different reason. And even you guys that were in class yesterday, I don't think we reviewed this at all. I don't think we've done it. We've done this definitely when we did tangents. All right, tangent day. We did this theorem. Dylan, what's perpendicular? Everyone ready? Radius drawn to, what's point T called again? Point of tangency. So radius drawn to point of tangency is a right angle. So 2 different reasons how I got the right angles. And now you guys can finish it up. What do I still need to say what though? Right angles are congruent, and then you can say angle. And then get going on the assignment. Just make sure you wrote they were similar and not congruent in your statements. Don't give up on me tonight. Get as much down as you can. If you get stuck, ask me about it tomorrow.